Black math! Give me some math and I'll give you some flack. Black math!
You got no funny.
You got the no.
Make sure you're hitting my spot.
I know.
Where do you usually sit there?
This is my spot. He usually sits trash
Oh,
can.
right.
One day he just decided he was going to steal my spot.
I used to sit there.
I know, I have to steal Emerson's
Oh, you
spot,
did?
and Emerson stole
actually did.
Nathan's
You actually
spot.
stole his
So Nathan's
Yeah.
best place. We're all happy.
Yeah. Yeah.
I
I sat
said
there
that
before
really
he came back.
was.
No, thank you. Oh, okay.
You guys already created your own seating chart. Then Xavier messes everything.
Oh, yes,
Yeah,
Xavier,
for real.
move.
I am the chaos.
Move.
FR.
Xavier needs to go sit by himself.
Nope.
I am but a simple
It's
agent.
in the hall.
I am but a simple agent
Guys,
of chaos.
go sit
trying to make the
beside
world a more
yourself.
Interesting place.
Go
Get
sit-
out of here.
The
Go
trash.
sit in the trash can.
Roasted, roasted.
Sit. Nathan,
Sit there.
we have a problem.
Ah.
Nathan
My
doesn't know
seat.
this.
So I took his seat, and then he took your seat.
Dude.
It's Xavier's fault.
Dude.
How is it my fault?
He was
This
my
wasn't
seat.
in California.
You stole Emerson's seat.
You started
You
the
could have sat
chain.
there, or there, or there.
Oh, you-
All right, guys.
Started the chain, Xavier.
We're doing 87 and 88 today. This first one is pretty chill. We're just doing five properties. And I think we've talked about it before, but it's pretty self-explanatory. Hey, I'm talking, so you're not.
Hair.
Okay, so, and then 88 is, we're talking about surface area. So, here's the first property of algebra.
How about no?
Nope, that's not it. The commutative.
Oh, is that the multiplication one?
You mean confusing, right?
That's the thing with the addition.
What is your shirt say?
Yeah, so it works with addition and with
Wow.
multiplication, but not with subtraction and
It does
division.
not mean you can go both ways.
So A plus B equals B plus A.
Yeah.
Doesn't matter what A or B is, you can reverse the addition. And you can reverse the multiplication,
Yeah.
okay? But this does not work, does it?
No.
And this does not work, does it?
No, mate.
Oops.
Entry, Henry.
So you can't reverse division or subtraction, because remember, subtraction and division are kind of dumb.
Yeah.
But you can do that with addition and multiplication. This is called the commutative property. What's a good way to remember that?
Commute.
What's a commute? What's a commute?
Going somewhere.
Yeah, going somewhere. So
Go
usually going somewhere is the same route and the same distance as coming back.
Yes, sir.
So that's a good way to remember it. Good job. Flack attack for you.
Like when you go on a bike and it has the thing in the back for your stuff.
What?
Hey, Henry, can I have my seat back, please?
Xavier, can I have my seat back, please?
Like
No.
commuting
They
to work.
Yeah, so do you need to
Come
move
on, I don't
away
wanna
from the
sit there
light
again.
switch?
What?
Do you need to be away from the light switch, or can you handle being there?
No.
No, I can handle the
The
responsibility.
problem is
Okay.
he's in Xavier's spot.
What about Austin's seat?
No.
All right,
Austin is
So-
on my spot.
If someone
That's
steals
one.
my spot, they
Here's
will
another one.
feel pain.
the
I like to see you
associative
Okay.
property. You guys know what the associative property is?
Association.
Yeah, so association deals with three or more terms, okay, or three more people. Like, who do you associate with?
My brain hurts.
So in this situation, A and B hang out, but C is kind of isolated. But this
That's
is
how I
always
feel
going
when I
to
see
equal,
What an AI.
okay?
Whoa.
So you can put the parentheses in different places and it works. And this
Why would
does
you ever
work.
do that?
This does work with multiplication as well.
Are you sure?
Positive. So you can try it with actual numbers if you want.
But what if it's
but it
negative?
works.
Could it have been
Negative
B,
numbers
C?
work.
But you said it's positive.
Yeah, for sure.
Positives?
What?
You said it's positive, but what if it's negative?
It's
Lol.
negative.
You just gang up on Ginger.
So if you think about it, like 5 plus -3 plus -2. What's 5 plus -3?
Negative.
2 plus -2?
0.
0. So what's 5 plus
Okay, we're saying.
-3 plus -2?
0.
5 plus -5 is also 0. Okay?
Yes, sir, bro.
So it works with positive and negative numbers. Good question. Does it work with this? 5 minus 3
No.
minus 2?
No,
Your gut tells you no because subtraction is dumb, right?
but you can.
Look at this. What's 5 minus 3?
2.
2 minus 2 is
0.
0. Well, let's try 5 minus 3 minus 2. What's 3 minus 2?
1.
What's 5 minus 1?
4.
Not 0. So no, this doesn't work with subtraction. Makes sense. So basically, the biggest thing you need to remember with these properties is multiplication and addition are cool, subtraction and division are dumb.
No, they rule.
And it doesn't work with division either. So 12 divided by 6 divided by 2. 2 divided by 2 is 1, right? This is 1. But what's 12 divided by 3? That's 4. That doesn't work. So see how parentheses make a difference when you have a bunch of division problems. Okay,
Division.
associative property, commutative property works with multiplication and addition, and so does associative property, multiplication and addition only. Okay, here's the easiest property in the history of math. It's called the reflexive property.
How about no?
It's a synonym for
Reflexing.
What does your reflection look like?
a reflected version of
You.
The same as the.
It looks like
two
Mr.
numbers
Flack.
that are the same.
Yep, that's it.
Why
Guess
would we
what?
need
A
this?
number, any number, equals itself.
Or does it?
Oh.
Wow.
No, I'm done. I'm done.
That's too confusing.
So.
Why would
My
we
brain
use this?
hurts.
negative
I'm just done.
8 million.
Why do we use that?
Why would this ever be a problem?
Yeah.
This is.
Believe it or not, we use that more than any other property. In geometry, we use that a lot.
Geometry sucks.
You're just like, yeah, it says 3 right there, so I guess it's 3.
Literally.
That's the way you. Yeah.
3 is 3 ones.
So it does, when you're trying to prove that line segments are congruent, the same length, and you're proving that this is congruent to this, and then you have to prove that this line segment of this triangle is congruent to this line segment of another triangle, but that is the same line segment, you have to say that that equals itself.
Yeah, why?
And the reason for that is reflexive property. Yes.
How about no?
How about yes?
Well, why is it reflex?
equals no.
How about why?
Why does reflection?
Yes.
It's kind of like reflection. Reflection.
Well, then why isn't it reflective property?
Isn't that crazy?
That's a good question. I don't know.
You wish you could wear jeans like
Get out of here.
It should be called the reflective property. Actually, when my geometry students do that, I give them credit anyway because it makes more sense than reflexive.
That's very strange.
Get out of here.
You wish you could actually.
Okay, what's symmetric mean? What's symmetric mean?
The same on both sides.
Yeah, same on both sides. So you would think that this would be symmetric, but it's not. So basically,
Because you have to put the A backwards.
get ready to blow your mind. Ready? If A equals B,
Whoa.
No, it doesn't.
B equals A.
then B equals A.
Actually, you have to put it in reverse for the.
Didn't read a pen tree.
And believe it or not, we use this a lot in math as well.
No.
Just
In
say the same
geometry.
number.
You don't.
3.
Mr. Flack, can you give us time to work together again?
It's 3
Yeah, I think that'd be great.
Good.
You guys did really well last time.
Did you give us all our 3 points?
Guys,
Yeah, I gave you
3
your
equals 3,
points.
and 3 equals 3.
Okay, now this last one, we're gonna go on a little bit of a logical journey.
How about
Okay.
no?
So here's what I mean by logical journey, okay?
You don't.
Let me just give you a first example. If it's Sunday morning, I go to church. If I go to church, then I have a bagel. If I have a bagel, then I'm not hungry for lunch.
I am.
Okay, so if it's Sunday, then I'm not hungry for lunch. You see how I got from A to B?
I actually have a bagel on Sunday.
I'm
Oh.
hungry every day.
My church doesn't have bagels. They used to have apple
My
fritters.
church
My church got bagels.
This,
Einstein froze bagels.
so I went on a little transportation. So this is called the transitive property.
Like transit from Black Ops.
Yo.
Lol.
Stop.
So,
Cheat.
yeah, what is a transit or a
Yes,
transient? You guys know what a transit or a transient
bus.
is? Yeah, it's a
A
bus.
transit?
It goes on a little journey.
I didn't know this.
So do you see that logical journey that we did? If it's Sunday, then I go to church. If I go to church, then I have a bagel. If I have a bagel, then I'm not hungry for lunch. So if it's Sunday, I don't usually eat lunch because I'm not hungry for lunch. Okay? That's not true. I skip the bagel and I have a really good lunch.
I eat 3 bagels and then I still have a really good lunch.
Dan, does your church have donuts?
Now we have bagels.
Sucks to suck.
Then it blows the.
Technically, they're both holy.
Oh,
Okay.
God.
no.
Oh, stop it. Ah, my head.
If A equals B and B equals C,
Wait, how is it spelled this Flack?
C equals B.
then what? Hey guys, look, if A equals B and B equals C, then
C
A
equals D.
equals
C equals A.
C.
A equals C or C equals A. Good. Okay? So if something equals something else and that something else equals something else, then that first thing equals that last thing. Okay? So for example, if I go to church, then I eat a bagel. If I eat a bagel, then I'm not hungry for lunch. So if I go to church, I'm not hungry for lunch.
No, if you're not here for lunch, you're at church.
What if you have a donut at church instead of a bagel?
Oh, then I'm definitely not hungry for lunch.
Absolutely.
No.
I have a donut. I can have a
Because
donut.
you get one donut and then you get another donut and then you get
Yeah.
another.
Does that mean that if you're not hungry for lunch, then you're at church?
You know what?
Good question. So that's the reverse of this. That would be the symmetric property. If I'm not hungry for lunch, then I'm at church. Then it's Sunday. So good observation. That's a Flack tech point.
Right there. That's couch potato. Yeah.
No, round it up, bro.
Okay.
Hurts.
That is basically lesson 87. Okay.
Hey, Emerson.
Emerson.
So in your homework, you're going to have things like this, and you're going to have to say, what property is this? So good luck with that. You're the only one paying attention.
Yeah, thanks.
Yeah, good luck with that. All you guys who took notes, so good at that.
Thank you.
Just kidding, you stink. What? I didn't say that.
Emerson's just like,
What does it matter if you have a different type of bagel?
That's my hand shaking myself.
That's the beauty of geometry and math. It's like, what if this rectangle's like curvy, or what if it's like that? No, there's no hypothetical situations. It's all logic.
Get out of here.
Go ahead and shake this live handshake with myself.
Mr. Flack, what
Yeah.
if you have a brown bagel?
This is mine.
But it doesn't have any holes?
hey, Emerson.
Hey,
Then
that
I
looks
use
like
silver or
That's called a piece of bread.
Mr. Flack, what's your favorite type of donut?
I used to like buttermilk bars,
I'm good.
Oh.
what?
but
Those two?
those, oh my gosh, those fill you up like crazy.
Those are-
disgusting.
That's diabetes in a ball.
It is.
Damn, wait.
Bro, doesn't your fingers look weird like this?
Look at it and you
Look at your
immediately have diabetes.
No, they don't look weird.
Not like
I
that.
have diabetes type 2 because I did a long John
Nathan, I gotta show
and a
you
Slim
my.
Jim.
Okay, ready? So stuff right.
Where is it?
Is that your?
Mine.
Okay, guys.
Stuff.
If I wanted to find
The surface of an area.
Can't find it.
the surface area of something,
You see?
Areas.
Maybe I'm close.
hey guys,
Hey, looks like a battle pass.
if I wanted to find the surface area of this box, what does that mean? What does that mean to
All
find
the
the surface
different
area?
sides.
Okay, so let's say that this that this Kleenex
Hop it,
box
Mr. Flack.
is 4 inches by 4 inches by 8 inches.
So that makes it tissue box.
Okay, so how do you find the surface area of this box that's 4 inches by 4 inches by 8 inches?
You add them up.
Can I just say,
You have
that
to
is
find
not
the
4 inches
area
by
of
8
each
inches.
rectangle, or each thing majiggy.
Hop,
That adds
hop the
together.
med
Front,
kit.
back, top, bottom, and then
Hey,
side.
I know the answer. I know how to do it.
It looks like it's 4 by 4 by 8. Let me just check the dimensions here.
Mr. Flack, I know how to do it.
Oh, it's centimeters?
No, she bugging. Makes us vain.
Mr. Flack, I know how to do it.
Oh, it's 8.4 inches.
I
Sorry.
need minis, I need minis.
Yeah, how do you do it, Emerson?
Okay, so what you do is you multiply 4 times 4, and then multiply that number twice, and then do 8 times 4, and multiply that 4 times, and then add those numbers together.
Yep. So look, this is the front. You guys see the front here?
Facts.
Yes.
Facts.
Plus the back, which is the
Facts.
same
I just said
thing.
that. Liberty Mutual.
And then what'd you do, Emerson? Hey, guys, let's do this a little differently, okay? So let's say
Only pay for what you need.
Liberty.
front and back.
From is there.
So you could do left and right.
Joe's just walking.
Hey, guys, just be quiet.
Yeah, shut up.
Left plus right plus top plus bottom, right? Or you could do it a different way. You could do it like this. You could do top plus bottom plus what I call the lateral area.
It's
Now
not
the
what you
lateral
call
area-
Lateral area. It's just a lateral
You
area.
got the top and the bottom.
Los Angeles.
Right? So you got- So you got these squares on top, but then you've got this rectangle that wraps around the whole thing. Do you see this? What happens if you unwrap that? It looks like this.
8 times 4 times 4.
Cold now.
So if you unwrap the midsection here, the lateral area, let's stop doing that. Then that's just one big rectangle. Do you see it wrapped around? If I unwrap the whole thing and spread it out, okay? Hey, if you need to go out in the hall and make funny, stupid noises with your mouth, go for it. Don't come back, okay? Go, get out, go. Don't come back.
I'm not making noises.
Fine.
Okay, so look at this. This is 4, 4, 4 all the way around. What's this represent?
16.
What's this represent of this Kleenex box? What is that called?
The bottom.
The distance around, what is that called?
The perimeter.
Perimeter, good job. So this is the perimeter, and then this perimeter, this is just the height.
Check this out.
So the lateral area is just pH. pH stands for perimeter times height.
Mr. Flack?
Yes.
You made a mistake.
What's
Mr.
that?
Flack.
Spelled that wrong? Yeah, I know.
Yeah.
So you just got a 4 by 4 top, a 4 by 4 bottom, and then you got pH. So that's 16 times 8. What is that? What's 16 times 8? 128.
You gotta grab it down.
So 16 plus 128. Yes, question?
That equals 150, 160.
160 square inches.
Mr. Flack, you made a
Yes.
mistake on the board.
What did I do?
You put a J in height instead of an I.
Yeah, it's kind of weird. I was having a rough day.
Okay, Mr.
Okay.
Flack.
So that's for a rectangular solid.
Does that mean I got free from something?
Now, here's the cool thing.
Do the med kit. You just dropped the med kit.
Throw basketball.
Here's the cool
Mr.
thing.
Flack, why'd you drop the med kit?
Here's the
Through the med kit.
here's the cool thing. You can apply this to really any solid that has the same top and bottom, even if it is a cylinder. Okay, look at this.
Whoa.
You're not correct.
Right?
Not much.
So that's the surface area is just the top, which is a circle, plus the bottom
Plus the top minus
Plus-
the sides.
LA. That LA is still a rectangle, right? And then what do we call that? Instead of perimeter and a circle, we call it circumference, which is always the same. It's just circumference. It's just pi times diameter, right? So those are the same as the mouth noises. So don't do that either. And then times height. So this is just pi dh. Instead of ph, it's ch. Well, c is just pi times diameter. So it's just pi dh. Let's not do that.
Okay.
Okay?
So we're not doing pi times dh?
Yeah, you are when you do the LA.
What happened now?
So you got pi r squared, because that's how you find the area of a circle, plus another pi r squared,
Antonio?
plus pi dh. Or 2 pi rh. Okay?
GTS.
All right, well, you can do the same thing with anything. Look at this big, weird, awkward, triangular prism. Look at this. Can you find the surface area of this triangular prism? Well, in this case, you could do the top and the bottom, but what makes more sense for the top and the bottom?
Sides?
Yeah, so basically you've got the same shape, the top and the bottom. So here's the top, which we don't really call it the top because it's not on top, but you could take this and turn it up. So now you got the same shape on top and the bottom. And then what's the middle going to be again? What's the middle? In between the top and the bottom, the two triangles? What shape is that all the way wrapped around it? It's just a rectangle. Okay? So what does that look like? It kind of looks like this. So 3, 4, 5, right? So remember, that's just pH. So this is 1/2 BH, 1/2 base times height, 1/2 BH plus pH. So all you have to do, guys, is find the area of the top and the bottom, or in this case, the front and the back, because that middle lateral part is perimeter times height. Okay? So what is that? 3, 4, so what is that? 6 plus 6 plus 12 times 16. What's 12 times 16? 192. So you get 200. Did I do that right? Okay. No, I didn't. You could have caught me.
Where do you get 200?
Yeah, it was 200.
192 plus 12 is 104 or 204 square inches. Okay? Could have gotten a free problem set.
Where's the 12?
See the top
Oh, yeah.
plus the bottom plus that lateral area, which is just perimeter times height. Okay, now I'm going to give you a problem. And if you get this right, I will take away one of your homeworks.
Yo!
Which, guess how many no, I'll just give you a free problem set. But you just can't use it on 88 because I want you to do 88.
Bruh.
Remember, have to do one. I'll give you all a free problem set if you get it. And you can work together.
Oh.
If If you work together and get the right answer, I will give you a free problem set.
Austin, what's the answer?
Okay, I'm gonna clear the board.
You can go get a calculator, Austin.
So guys, a good thing to write down is how to find the area, surface area of a right solid.
What is that?
What does that mean? What's a right solid?
A solid with a right angle.
Okay, yeah, well, the right angle is from the base and the sides form a right angle,
It's not
but the
wiggly.
base could be any shape you want
It's not wiggly.
as long as, listen to this, it's the same shape on top as it is bottom. Okay? So here's the deal. Let's say you have to repaint your mailbox. So here's what your mailbox looks like.
Why is it sideways?
It's just easier because look, if it's sideways, then we have a top and the bottom that are the same, right?
Oh.
Do you see the top and the bottom that are the same?
We have to do semicircles.
All right, so now listen, this is what it looks like. These are the dimensions of that mailbox top. Okay, and then the height is 10 inches. Okay, now if you find the surface area of this mailbox, then you get a free problem set. And you may work together. So how do you find the surface area? Area of the top plus the area of the bottom plus that lateral area. Now how do you find the lateral area?
You have to get all the numbers.
Did you guys listen? Why don't you just look at the notes that you just took? Oh, you didn't take notes. How do you find the area of that middle part?
Something
You would multiply the,
DH.
you would find the top and bottom, add the.
That's the top and the bottom. How do you find the area of this middle part?
Do it to the sides.
And then, no, you do,
About that.
you do 8 times 10.
Just a rough estimate is probably fair.
No, you can do it one at a time, but there's an easier way to find the lateral area.
You do,
We use multiply. Multiply the sides, right?
Nope. Were you guys
Whoa.
listening? How do you find the lateral area?
You're busy being quiet.
All right, well, I'll probably have to tell you how to do this because you're not gonna get it.
would be 28 times 10,
Nope.
something like that.
You know, I'm gonna take a hard pass on this one.
Okay, write this down because you're not smart enough to remember it by yourself. And you think you are. You think you can just sit in here and learn math, but you can't. You got to write stuff down. These are complex formulas, guys. What do you expect is going to happen? You think you're going to just write down the solutions, answer from the solutions manual, and then you're just going to do great on a test that you don't Google? You expecting that to happen? Write it down. This is what math class is going to look like for the rest of your math career, which for most of you will be 4 more years. Okay?
I died and choked it.
Surface area is the top plus the bottom plus LA. And LA is always the same for a right solid. It's just perimeter times height.
I was saying that the whole time.
Nope, you
Sure.
weren't.
I actually was.
Same kind of configuration.
Okay, so find the area of the top, find the area of the bottom, add those together, and then add the lateral area. So here's the surface area of the top is this, a 6x8 rectangle plus this semicircle, which is pi r squared divided by 2. So this is 9 pi divided by 2. So this is 48 plus, what was that? Fourteen point 14.13. Okay, and this is all times 2 because it's the top and the bottom. And then this is perimeter times height. So this is 8 plus 6 plus 8 plus pi times diameter divided by 2. So this ends up being 31.42. That's perimeter times height, which is 10. So this ends up being 62.13 plus 62.13. That's the top and the bottom, plus the lateral area, which is 314.2. Added together, you get 438.46 square inches.
Black man.